I think 5% has joined. Someone else might be joining. Danya, Jalpa, and Tukaram. Okay. So if there is no question regarding the initial sessions, I'll be going for this. Any question about past session? Dr. Tukaram, Dr. Danya, Jalpa, anyone? So today you should have two sessions. One, you need to create examples where you apply which test, and then we'll be going for non-parametric test. So the first, and actively use chat box. And if you don't use chat box, that means we are not going to learn. So first I will be uh, I think you will be able to participate in that. So let's use chat box. First thing, you write down variables from which you can find out mean. I will give examples: diameter of RBC. You also write down at least one variable from which we can find out mean. Everyone need to write down variable from which we can find out mean. You can write height, weight, chest circumference, head circumference, or numbers, or the visual acuity number, age of all students in the class. Okay, so now from where we can find out percentage. For example, the person is believes in God or not. You find out some variable from which you can find out proportion or percentage. It could be tall or short, like this. At least one variable, smoking or not. Now, the next thing is, suppose we want to find out, in this case, we have a 40 student, n is equal to 40. Mean is equal to 140 centimeter, and standard deviation is equal to 10. In this case, 95% of the observation will lie between mean plus minus 2 standard deviation. So now, if I tell you that if a person having 155 centimeter height, does it belong to this group or not? Yes or no? Does it belong to this group? 155 centimeter? Yes or no? Yes, because range is 140 plus 22 standard deviation to 140 minus 20. That is between 160 to 120. That is the range, 160 to 120. So 95% people will be in this range. But now, suppose it is asked to you that how many children will lie between 130 centimeter to 140 centimeters. Then do you have answer to this? I think I should have written to all. Written to all, everyone. Suppose my question is between 130 to 140, how many students will be there? Anybody can answer this? Our mean is 140 centimeter, total number is 40 centimeter, and standard deviation is 10 centimeter. The question is how many lie between 130 to 140 centimeter? Any answer? For that, you need to find out Z value. Z is equal to, if you take 140, then X minus me divided by standard deviation, that is Z. Very simple. So in this case, Z is equal to 140 minus 140 divided by SD is equal to 0. So 1Z is this for 140. But for 130, let us take Z1 is equal to 130 minus 140 divided by 10 is equal to, if you take absolute value, it is 1, or you can take minus 1 also, 1. Z is equal to 1. So 1 minus 0, 1. So Z, what you need to look at, standard deviation, mean plus or minus 1 standard deviation. That covers how much? So you should remember the normal distribution curve. Normal distribution curve says that mean plus minus 1 standard deviation will cover around 68%. So that means this will cover 34%, half of that. So 34% of children will lie between the range 130 to 140. But instead of this one, suppose it comes zero point 0.7, zero point 0.5, so what do you do? So for that, you need to learn Z table. In this case, 34% of 40 will be somewhere around 16 or so, 15 or so. But if you have a larger data, then you need to find out the Z table. From Z table, you find out the probability, and from probability, you find out percentage. Suppose Z table shows that it is zero point 0.8, and another Z table at the other level, it shows that it is zero point 0.7. Then between zero point 0.8 and zero point 0.7, it is 0.1. So from Z table, you need to look minus zero point 0.7 is 0.1. Now, if you do not know how to read the Z table, you write in a group. So next time I will show you the Z table. I will tell you how to look at the Z table and then probability. That zero point 0.1 is equal to 10%. 1 is equal to 100. So zero point 0.1 is 10% of the population lies between 0.8 and 0.7. So from the value, you find out the distance from me, that is Z, and from Z, from the table, you find out the probability, and from probability, you find out the population. I stop here as far as the use of standard deviation is concerned. And that question I may ask you in a group, and it could be a lesson. Any questions so far? So I repeat, if you are given a population of, let's say, 10,000 population, and you are asked to find out the mean of the population, you should be able to find out. You should be able to find out standard deviation also. And from that, if suppose it is income, and mean income per month per capita is suppose 2,000 rupees, and standard deviation is, let's say, 100 rupees, then if someone asks you a question, how many lies between the monthly income of 1,000 rupees to 500 rupees, you should be able to find out. Will you be able to do that? Yes or no? Everybody should try to write down whether yes or whether no. You have a population of 10,000. You have found out the mean of 2,000 income per month, and then standard is 100. Now the question is, how many people will have the monthly income between 1000 to 500. Will you be able to do it? That means no one is answering. At least 3% is attending. You should write down yes or no if you are attending the session. Yes. Okay. Fine. No, so now we go for the next. Now another question is, if you want to find out based on a sample, how many the population parameter we want to find out based on a sample. Let's say what is to be done for that. I give you example over here. And there is a 10,000 population. Is a population, and you want to find out whether the people are happy or not. Based on a sample, you want to talk about the population, whether the people are happy or not. Suppose you have taken a sample of 400 out of 10,000 population. And out of 400 people, you found that 300 people are happy. And you want to say that how many people will be happy in 10,000 population? Can you calculate that? Would you be able to calculate that? How many people will be happy? Any guess idea? So let us try to use a test. This is known as standard error of proportion. This is known as standard error of proportion. Here is the right. Now, when you use the standard proportion, let me have a blank sheet over here. We have a population of 10,000, right? We have taken a sample of 400, out of which 300 are happy, 100 are not happy. Based on this, you want to say that how many will be happy in 10,000 population? Let us keep it over here. So it will not be a simple percentage that out of 400, 300 are happy. So out of 10,700, 500 people will be happy. That is not the way you calculate, because when you take a sample, there is a likelihood that there will be a sampling error. And that sampling error, to uh, include that sampling error, we standardize that sampling error. So what we should be doing, that in this figure of 7,500, we need to find out there has to be some error. So this is a 300 is 75% plus minus 2 standard error of proportion that you need to add and subtract. And that standard of proportion for that formula is population proportion belongs to population proportion. Population proportion means how much proportion is belonging to that. So population proportion, that is 75%. That plus minus 2 standard error, that is the range. So these two standard error, if you want to find out, then standard error proportion is equal to root PQ upon N. PQ is 75% into 25% because this 100 is 25%. N is 400. So 75 into 25 divided by 400. If you take root of this, then you will find out standard error. And that standard, if you add 75% plus minus 2 standard error, then you will get a population proportion. So 7,500 is not the answer. Plus minus 2 standard error proportion, you need to do it. If you can't understand, then you can tell me. Now we come back to original sets. So one thing is where you use standard deviation when sample is given or population is given and individually you want to compare whether they belong to in sample or not, at that time use standard deviation. When you have comparing sample with the population, at that time you use standard error of proportion or standard error of mean. This you are supposed to find out. So here you should write down that population proportion belongs to sample proportion, that is P plus minus 2 standard error. This you should write down so that you can find out population proportion based on a sample. You have 1 lakh population. You want to talk about 1 lakh population based on only 300 people. You can do it. Take a percentage within 300 population sample, apply 2 standard error in that, and you can find out population. Similarly, if you want to find out population mean, take a sample, then population mean belongs to sample mean, because see 1 lakh population you cannot find the mean of all the 1 lakh populations. Take a sample of 300, 400, and sample mean plus minus you take 2 standard error. If you do plus minus plus, you can find out the population mean. But how to find standard error? In this case, standard error is equal to, basically standard is equal to SD square upon n or SD upon root n. So whatever you want to take, so SD divided by root n. That will give you standard error. Now, it may be a little bit difficult, but you should remember that whenever you take a sample, there is some error. And this sampling error, if you standardize, it is a standard error. In this case, if you want to find out standard error, SD upon root n will give you the standard error. Or you can say root SD square upon n, whatever you want to take. This will, you will be able to find out population mean. But reverse way, if you want to find out whether sample is representative or not of population, whether the sample represent a population or not. If you want to find out this, then you need to find out Z. Z measures the distance between population mean and sample mean, or population proportion and sample proportion. It depends which data you are looking about. And this Z, if it is more than 2, it is probability that it occurred by chance is less than 0.05, and you can say that this is significant. So you ultimately find out Z. This has a two purpose. Standard of mean and standard of proportion has two purpose. One is to find out whether the sample is representative or not, and another use it based on sample you can find out population proportion or population mean. These are two use of standard of mean and standard of proportion. The next would be, if we have two population, when you are comparing two population, essentially you are taking two samples and find out whether the difference is significant or not. This is relatively simple because here Z is equal to x1 minus x2. That is the mean of one sample minus mean of another sample and divided by standard. This standard error was standard of mean, but this standard error is standard error of difference between two mean. This was a standard error of proportion, but in this case, it is a standard error of difference between two proportions. This is the difference. And this you can find out with same formula, but written in a little bit different connotation. This you can say that if it is a proportion, for example, albendazole and neem, etc., you are comparing 250, 300, 300, like this. How many recovered out of 300? In this case, P1 Q1 upon N1 plus P2 Q2 upon N2. P1 means successfully treated, Q1 means not. So in this case, 250 percentage to be taken out of 300, not cured is a Q1 divided by 300. This, if you can then take a total and root, that will be standard of difference between two proportion. Similarly, here in this case, if you want to find out standard error, then standard is equal to root, then SD1 square upon N1, SD1 square upon N1 plus square of SD2 upon N2. That will give you, and root of that, that will give standard error of difference between two mean. This is how you can find out whether the two population is significantly differ from each other or not. You need to find out Z. X1 and X2 you have, two sample mean you have. You divide by standard error. If Z is more than 2, P is less than 0.05 and it is significantly different. Similarly, in the proportion also, two proportions are given, P1 minus P2 divided by SE. SE you can find out by this method and you can find out whether these two differs or not. Maximum you need to use this one. And in AP info, to find out, this is a means command, this is a tables command, and how to use means and tables command, that we'll be looking at now. When the sample size is less than 30, then you can use t-test. In t-test, there can be a pair test, suppose before and after in the same individual, or one individual paired with another individual, then you can use the pair t-test. Unpaired t-test, in one group there are 30, another group another 30, but they are not paired. Or one group is 30, other group is 25. In such case, you can use the unpaired t-test. Now, for two populations, it is easier. But if you have three or more population, three or more sample population to compare, or three or more sample to compare, in that case, t-test or standard of difference between two mean will not be useful and you need to go for f-test. In this case, instead of two sample, the proportion you want to compare and is more than 3, then you need to use chi-square test. So if you know whether it is a means or proportion, then with this simple formula, you can find out which test is to be used. But now we are going for something different. In one case, for example, use data like this. You had given the treatment of only diet therapy. Another patient, you gave only allopathic medicine. Other patient, other group of patients, you took plus diet plus allopathy. And fourth group, you gave a diet plus Ayurveda. And now, very small sample, you have only 5 patients and you want to see the improvement over here. In this case, the reduction of cholesterol level only in the diet was, let's say, 34, and another patient 23, 30, 35, 24. If only allopathy used, then it was, let's say, 56 to 54, 43, and it was something like 32. But when applied diet plus allopathy, the reduction was 60, uh, 57, and then the 45, and then there was the 3 like this. This is a series of patients we are taking. One patient, second patient, third patient, fourth patient, individual patients data, 5th, 6th, 7th, like this, right? There can be 5 patients also in somewhere. In diet plus Ayurveda, it was something like the 87, 76, 54. These are independent patients. They are nothing to do with each other. There are 16 patients were treated like this. This was the data. Now we want to find out whether the data is homogeneous or not. Is there a significant difference? So for such a small thing, we need to use non-parametric test. And we are going for non-parametric test. That is a Kruskal-Wallis test. Before we go for that, if there's any question in this, you can ask me that. Any question? So let's go for that. Kruskal-Wallis H test. This is a non-parametric test. If very small sample size, still we can use this. And the theory is very difficult. You may find it difficult, but practical calculation is very simple. And when you use computer, it's still simple. Right? So here you want to compare two or more than two population because two population have many things to calculate. But here we have three or four groups, and we want to do it. This n, all n, n1, n2, nk means four groups, five groups, k means five groups, six groups, seven groups. If there are seven groups, there is n7. And in this, let's take an example. Before example, it says that k sample means four samples, right? We'll be doing taking a rank and total of each rank. This formula, forget right now, we'll be going how to find out h. Just like we are find out the z, we are find out h over here, and then we will look at the corresponding table. Now, this is when you come to a practical, it will be very simple. In this case, K distribution, that means number of samples, four samples, five samples, it is identical. This is what hypothesis null says. But even one differs, we'll say hypothesis is wrong. And we can say there is significant effect of some kind of therapy.